In this video, I'd like to share with you some of my construction techniques, how I went about testing the product, and offer my thoughts on how the project worked out as a whole. The volute chamber was made using an additive layer method, kind of like 3D printing, but much slower, requiring a lot of measuring, cutting, and gluing. This method suited the project perfectly, as I only had limited tools and materials, and I could make it just out of laminated plywood. Although time consuming, it is incredibly simple, and I followed the plan without hiccup. Luckily, I found this old bearing from an angle grinder which was being thrown away, and a long metal tube which I wanted to use as a shaft. The problem is how to connect them. There are no convenient mating surfaces, and I don't have any metal working tools. They also need to connect firmly to both the impeller and the housing. I carefully measured the mating surfaces and cut a small piece of wood to act as a coupler. I drilled a hole in the shaft with the closest fitting drill bit I had and shimmed the gap until it was square. I then added the tightening screw and secured the shaft with a locking bolt. I countersunk the bearing into the base of the volute chamber and cut a groove in the impeller. Then I screwed it all together and gave it a quick test. Delighted. Next I cut my hand using the angle grinder. I cut the bolt using the angle grinder. I moved on to finishing the rest of the construction. I had to use this dustbin to funnel the water into the turbine since I couldn't find a pipe of the right diameter. It was slowly occurring to me that this was not going to be a very slick looking project. As soon as I had it running, I knew I wasn't getting the RPM I had expected. I was ready for disappointment. By experimenting with the position, I found that by creating a vortex in the bin, the power would increase considerably. I'd worked out my max theoretical power to be around 240 watts. Now I just had to measure the actual mechanical power being transmitted to the shaft. To do this, I needed to measure both the torque and RPM at full capacity. I built a simple strain gauge using some of the bits and pieces lying around my shop, and calibrated it by weighing known quantities of water. I then attached it to a 30 cm lever with a friction fitting around the shaft. As I tightened the friction fitting, I measured the displacement of the spring and counted the revolutions per minute. The highest power I recorded was 25 watts. My turbine is roughly 10% efficient. In conclusion, these 4 LED lights use around 24 watts. But before we can use them, we have to take into account the gearing and electrical generation losses, as well as the losses associated with charging and discharging. Even more importantly, the RPM is nowhere near that required by the generator. This would make the gearing losses even more cumbersome. Well, overall, I realized that this won't be powering a house anytime soon, but the real point of the project was to learn about turbine design in practice, to overcome the challenges of constructing something with minimal materials and to work with hydroelectricity even on this very small scale. Thank you for watching. I hope you have a great day.